Bonsuelo Mathletes, here we go. We're actually going to do something to the graphs that I gave to you last time. Actually, we're not going to use those too much yet. I'm going to probably just hand you the graph on a silver platter today. Okay, remember I said, and you don't need to write anything down just now. Remember I said what we're going to do. We're going to take a basic graph, and we're either going to move it up, down, left, or right. Like here, I'm moving something right. Okay, we may stretch it. Oh, that's sad. We may compress it, smash it down kind of, or we may flip it over. That's really a sad looking graph. Anyway, so that's what we're doing. Okay? Now, the three things you're going to be doing, not today, but entirely, over the span of these lessons. Stretch or compress, that's the first. Reflect, and then shift. Move it up, down, left, or right. I'm going to deal with the shifts first. Not that they're the most important. And as a matter of fact, when you've got like all three of those together, you'll do the shifts last, and I'll mention that again later. But they're the easiest ones to understand. Okay? So what we're going to... This also is referred to as a translation, but what we're going to take a look at are graph shifts. So all we're going to do today is take a graph and move it up, down, left, or right. Okay, if you take an equation and you put the quantity x minus h. Now, is there actually going to be a letter h? No. What am I talking about like here? X minus 5. Okay, that's what I mean by, or x plus 5 would be x minus a negative 5. Okay? So it'll be a x plus or minus a number, okay? If you put that in place of x in the equation, then you shift h units in the horizontal direction, horizontal being left or right. If you put y minus k, again, there'll be a number instead of the k, in place of the y in an equation, then you shift k units in a vertical direction, which is up or down. Okay, the first thing I want to do is make sure you can read the equation. If you can't read the equation, okay, it's, you're not going to be able to do what you're supposed to do correctly. All right, so I want to point out something. Again, don't write this down just yet. What am I talking about? All right, let's say you have this. Y equals the absolute value of x. Okay, so let's say you have that, and then you have y equals the absolute value of x minus 5. That's what I mean. It's like we're going from this to that. And the thing you have to figure out, first of all, is that number with the x or the y? And if it's with the x, then you do it left or right. You shift it left or right. If it's with the y, you do it up or down. And the next thing you have to do is figure out, okay, if it is with the x, we know it's left or right. Well, do you go left or do you go right? And if it's with the y, okay, we know we go up or down, but do you go up or do you go down? Okay, so that's what we've got to figure out here. Okay, and then after we figure out how to read the equation, then we'll actually, start taking a look at what a graph looks like. Okay, so how to read the equation. Given the graph of y equals x squared, how would you, and I'm not going to go into like a big explanation of it right now. I'm just going to ask you to kind of look at it, tell me what you think, and then after a while, I'll kind of give you something that'll maybe be a little more concrete. Okay, so given the graph of y equals x squared, how would you graph y equals x squared minus 7? Now, so what's the difference between y equals x squared and y equals x squared minus 7? It's obvious, or at least I hope it's obvious. It's the minus 7. So the question is that negative 7 with the x or with the y? All right, now, so think about what you think it is. And I'll just, if you're not sure, pause the video and think about it, but don't spend a lot of time, just kind of like gut feeling, what do you think? Okay, and I'm assuming you've thought about it for a little bit. What happens here? The 7 is with the y. Okay, it's not with the x. And I'm going to tell you the way, I'm not going to try and go through all the theory of this because this is a complicated enough idea as it is, but this is what I would tell you to do, okay? If you're trying to figure out if the numbers with the x or y, ask yourself, can I put that number on the same side of the equation as the y? It's a yes or no question. Okay, don't worry about whether you can put it with the x or not. That's not going to help you. The way you want to look at it is, can you move this 7 over to the y side? And if you can, then it's with the y. And if it's not, then it's with the x. So can I move this 7 over to the y? Sure, I can add it to both sides, and it'd be y plus 7 equals x squared. Okay, so fine. So I know it's with the y, and so it's either up or down. Now, is that a shift of positive, up or down, positive 7, or is it a shift of negative 7? Now, here's kind of where it gets weird. And let me back up to something for a second, and maybe this will help. Remember how I said I don't want you to do this for the linear equations? I don't. But I'm going to talk about linear equations for a second. What if we had this? Y plus 4 equals 1/2 x minus 12. Okay, hopefully you recognize that's the equation of a line, so you wouldn't do any of this. But remember, what is this? This is the point-slope form. Okay, well, what's the point? The point was 12 comma negative 4. And back when I talked about lines, I explained why you take the opposite of this. In other words, it appears to be negative 12, but it's really positive 12. And if you want to go back and listen to the video on lines, I explained why. And this appears to be 4, but actually it's negative 4. Okay? So we took the opposite of what it appeared to say. Well, again, I don't want to go into a lot of theory here, but basically it's the same idea. Okay? So this appears to say that the y is going to be shifted 7, but actually the y is shifted negative 7. Okay, well, think about it. Vertically, up and down. Okay, there's up and there's down. What would you think positive is? I mean, I think common sense kind of tells us positive is up and negative is down. Well, again, what's this value? We're going to shift it negative 7 in a vertical direction. Again, why is it vertical? Because the 7 can be put with the y. Why is it negative 7? Because we picked the opposite of that number, just like we did when we dealt with point-slope form. Well, what's negative 7 in a vertical direction? We're talking down. Okay? That's how you would read it. Okay, again, I'm going to go on. If you have questions on, please ask me, but let's take a look at the second one. Okay, let's take a look at this. So again, we have a y equals x squared, but what's extra in this equation? The minus 3. Okay, is that minus 3 with the x or the y? Well, can I move this negative 3 over to the y side? No, I can't, because it's inside the parentheses. So since I can't put it with the y, it's with the x. Okay, well, x is left and right. It's horizontal. Okay, well, should we think of this as a positive 3 or a negative 3? Again, we take the opposite of what it appears to say. So we're going to shift this 3 in a horizontal direction. Okay, well, horizontally, do we think of positive as left or right? Generally, we think of positive as right and negative as left. So we're going to do this to the right. Now, how we do this, I'll get to in a little bit. I just want to make sure you can read the equation. Okay? So, for instance, on this first one, y equals x squared minus 7, if it had been plus 7, then we would have gone up. On the second one, if it's x plus 3, which it's not, but if it was x plus 3, we'd go to the left. Okay, so you need to know which variable, number one, which variable is it with, and number two, do you do what it appears to say or the opposite? Okay, so it appears to say on number one that you're going to go positive 7, but actually it's a negative 7, and on number 2, it appears to say you're going to go negative 3, but you go positive 3, which is to the right. Okay, all right, now, So if you have a question on that, ask me before you go on, okay? Now, these are kind of tough ones, at least at first. Why? Take a look at the examples 1 and 2 that we just went through, and take a look at these 2 examples. And there should be something that like sticks out like a sore thumb that these 2 that we're doing now don't have. And it's something I discussed the very first day of school. These things aren't written as equations. Okay? So what we have to do is we have to think of this as y equals f of x plus 3. Now, why is it y equals f of x? Because, it's like, it doesn't f of x mean y. Yeah, and this is kind of hard. So I'm going to, if what I'm about to say kind of throws you, just remember, just look at this as y equals and y equals, and look at it that way, okay? Okay, so I'm going to kind of attempt to explain why we write it y equals f of x plus 3. If we have f of x equals x squared, let's say, then what would f of x plus 3 be? Well, notice in place of this f of x, the entirety of x squared can be put in place of the f of x. Okay? Now, normally you'd put a y there. Why? Because the y represents all of that x squared. Again, if I'm throwing you here, just think y equals f of x plus 3 and deal with that. But I kind of want to give you, I don't like to just tell you to do something. I like you to know why it is. But so if you have any questions on this, if you don't have any questions on it, you just want to write y equals that, fine. But if you have questions on it, ask me, please, because it is a good thing to know why. Okay, so if this is x squared plus 3, what would we put here? Well, we'd put y. Therefore, y equals f of x plus 3, because this is a new function. Okay, this thing right here is a new function. It's kind of like saying this. It's going to be kind of weird, but it's like saying this is a new function g of x. And g of x equals x squared plus 3. But instead of putting g of x, I'm just putting a y. Okay, so if f of x equals, don't write any of this down, by the way, this part here. Just listen. Or ignore it if you want. If f of x equals x squared, and I have f of x plus 3, that means there's a new function that's the f of x function plus 3. In other words, there's a new function that's x squared plus 3. Okay? And I'm going to leave it at that, because if I say, and like if you don't like this, like if this is kind of starting to throw you now, just kind of plug your ears and, just kind of hum so you can't hear me or something. But don't worry about it. But if you're kind of looking at it and you go, okay, I think I get what he's saying, or even if you don't get what I'm saying, but you want to know, just tell me and we'll talk about it. Okay, so you have to think of the problem like that. Now, let's just do the same thing we did up on the first 2 examples. Can I move this 3 over to the other side of the equation, which contains the y? Yes, I can. That's y minus 3 equals f of x. And you have to think of this f of x as an expression that contains an x. Okay? So, is the 3 with the y? Yes, therefore it's going to be a vertical shift. Is it positive or negative 3? It's positive 3, so it's 3 vertically. In other words, we're talking about up. And this takes some getting used to, okay? But get this now. If you have problems with it, stop the video, listen to it again, ask me questions, but get this now, because if you get this now, The next part, when we go to shifts, not when we go to stretch, compresses, and reflections, won't be as bad. If you don't get this now, you're not going to get the other ones. You know, the stretch, compresses, and all that. Okay, let's take a look at this one. Let's think of it as y equals f of the quantity x plus 10. All right, can I put that 10 to the other side of the equation that's got the y? No, I can't. So it's with the x. So it's going to change the x. It's horizontal. And the opposite of 10 would be negative 10. So we're going to do this negative 10 horizontally. In other words, what we're going to do is go left. Okay? And again, we're just reading the equation right now. Okay, let's take a look at this one. Again, you have to think of it as y equals the 4. Can I move that over with the y? No, I can't, because it's in the parentheses there. The 8, can I move it over? Yes, I can. So we have y plus 8 equals f of x minus 4. Okay, the 8's with the y. I like to do the horizontal ones first, so I'm going to look at the 4. The 4 is with the x. I do the opposite of it, so that's 4. And that's the opposite of 4 would be positive 4, so it's 4 to the right. And that's all you really need to write down is the number and to the right or the left. Okay, the 8 is with the y. I'll use negative 8, so I'll go 8, but the negative direction would be down. So whatever the graph is we're going to have, and I haven't given you anything yet. Remember, these are the things you're going to do to a graph that already exists, either a graph I hand you or an equation I hand you, a basic equation that I'm going to hand you. You'd go 4 right and 8 down, and I'll show you how to do that eventually. Okay, now, this is kind of a summary of how to read the equation. And you have to understand this. It gets kind of tedious always moving numbers to one side of the equation or not. So like on the very first example, okay, yeah, we moved the 7 over. You don't really need to. Okay, second example, you couldn't move the 3. Third example, we moved the 3. You didn't really need to. Okay, the next example, we didn't move the 10. And the last example, we moved the 8, but not the 4. But you really don't even need to move the 8. Okay, now I'm going to say this very slowly. And it's written down for you right here. Okay, I'm going to show you how to read the equation without ever changing it. Okay, in other words, just the way it's written. How do you read the equation? There are 2 things you want to ask. Okay, whatever number you're looking at, can you put it with a y? Okay, if you can, you don't necessarily have to. You may, it's fine. But if you can, then the number changes the y. If you can't, then the number changes the x. Okay, now here's the weird part. Is the number on the same side or the opposite side of the equation as that variable? Okay? In other words, if the number's changing y, is the number you're looking at on the same side as the y or the opposite side as the y? Okay? If the number's changing the x, is that number on the same side as the x or the opposite side of the x? Okay? And the key here is this. If it's on the same side, you do the opposite of what it appears to say. And if it's on the opposite side, you do the same as what it appears to say. Now, let's go back and look at the examples we've already done, and I'll try and show you how this works. And take this slowly, all right? And again, if you get this, it'll make the rest of it not easy, but much, much easier. Okay, I'm not going to rewrite the equations at all. I'm going to take the equations as they're written. So the very first example, y equals x squared minus 7. Okay? Look at the negative 7. Can I put it with the y? Yes, I can. I don't need to, but can I? Yes. All right? So therefore, I know it's with the y. Now, here's the second question. Is that 7 on the same side of the equation or the opposite side of the equation as the y? And why am I asking about y? Because that 7 is changing the y. Okay, the 7 is on the opposite side of the equation as the y. Therefore, you do the same as what it appears to say. And I'm going to have to go through a lot of examples here. So it's, again, what am I saying? It's with the y because I can put it with the y. That's the first thing. Second, because it's on the opposite side of the equation as the y, you do the same as what it says. What does it say? -7. So you go -7 in a vertical direction. Notice I didn't need to rewrite it to figure that out. Number 2, the -3, I can't put it with the y, therefore it's with the x. Okay, sorry, on number 2, the 3 is the number we're talking about. Can I put it with the y? No, therefore it's with the x. Okay, so is the 3 on the same side or the opposite side of the equation as the x? And why am I looking at x? Because the 3 is with the x. The 3 changes the x. Well, it's on the same side of the equation as the x, therefore I do the opposite of what it appears to say, so I go +3 in a horizontal direction, which is to the right. Okay? Let's take a look at these next examples. And I'm going to go back to what the original said here. I'm sorry, no, I don't want to do that. I still want to have it y equals. Okay, no matter what, you've got to have a y equals. Okay, let's take a look at the 3. Can I put the 3, this is an example number 1 on the second part here. Can I put the 3 on the side of the equation with the y? Yes, I can, so it's changing y. Now, is it on the same or the opposite side of the equation as the y? It's on the opposite side, so I do the same as what it appears to say. And since it says +3, I do +3 vertically, go up. Let's take a look at the second one, f of the quantity x plus 10. Okay, can I move the 10? First of all, which variable is it with? Can I move the 10 over with the y? No, I can't, so it's with the x. All right, now, since it's changing the x, is the 10 on the same side of the equation as the x or the opposite side? The 10 is on the same side of the equation, so I do the opposite of what it appears to say. So it's a -10 in a horizontal direction, which is left. Okay, the third one here, the third on the second part, so it's the 5th example total. Okay, the 4, can I move that to the other side of the equation? No. The 8, can I move that to the other side of the equation? Yes. So the 4's with the x and the 8's with the y. Now, let's look at the 4. Is the 4 on the same side of the equation as the x, which is the variable it's changing? Yes, it is. So we do the opposite of what it appears to say. So we go +4, which is 4 to the right. Okay, the 8, it's with the y, because I can put it over with the y, but I'm not going to. So is the 8 on the same or the opposite side of the equation as the y? It's on the opposite side, so I do the same as what it appears to say. It appears to say -8, so I go -8 vertically, which is 8 down. Again, you might have to go and listen to those again, okay? But generally, I don't rewrite the equation. Like on the very first one up here, right, I rewrote it. And this one I rewrote it, and this one I rewrote it, at least the first time I went through it. But you don't need to. If you don't rewrite it, you can still understand what the equation says. And, later when we get into harder examples, if you're always rewriting it, sometimes it actually makes the problem harder. Okay, so that's just how to read the equation. So what do you do? So without rewriting the equation, 2 questions. Can you put the number with the y on the same side of the equation as the y? If you can, then the number changes to y, and if not, then the number changes the x. Okay, once you figure that out, and you have to figure that out first, then is the number on the same side or the opposite side of the equation as that variable? So if it's on the same side of the equation as the variable that it's changing, you do the opposite of what it appears to say. If it's on the opposite side of the equation as the variable that it's changing, you do exactly what it appears to say. And you might want to go through and listen to that again. Okay, I think it would be helpful. But okay, having said that, let's take a look at an example. Again, I either have to hand you a graph on a silver platter, which is what I've done in this equation. Okay, I've handed you the graph. Now, you should know how to graph it. I've already told you how to graph y equals absolute value of x. But just for the sake of, starting out, I've given it to you. Okay? So what we want to do is graph y equals square root of x plus 2. All right. So the only number here that's new is this plus 2. Let's figure out, first of all, if it's with the x or the y. Can I move that plus 2 over with the y? Yes, I can. Now, if you want to, go ahead. Okay? But I'm not going to. All right, so then the next question, we know it's with the y, so the next question is it on the same side or the opposite side as the y? Since it's on the opposite side, I do the same as what it appears to say. So what do? I go plus 2 in a vertical direction, which means up. Okay? Now, I'm going to show you the long way to do this. And the long way to do it is probably a good way to do it at first. But after a while, if you can kind of do it, and after I'm done with this, I'll go back and show you a shortcut. But if ever you get to a problem that's difficult, and the more complicated they become, okay, they're more difficult, you always want to go back to this method. What we're going to do is make an XY table. Now, I don't mean I'm going to plug in X's and find Y's. What I'm going to do is I'm going to go to the graph and pick points that are on the graph. So for instance, here is a point 0, 0. And here is a point 1, 1. And here is a point 4, 2. Okay? I'm just picking those off the graph. All right? Now, what I'm going to do, without changing the x, I'm going to add 2 to y, to the y value. Okay? So I'm not plugging in x's and calculating y's here. It's not what I'm doing. So I'm not graphing by XY table. Okay, this is not what you're not plugging in x and calculating what y is. So we're not going to change x at all. So that's going to stay 0, 1, and 4. And what I'm going to do is take all these y values and add 2. And I'm going to plot those. So I'm going to plot 0, 2, 1, 3, and 4, 4. And then draw the graph. Okay? So what I've done is I've taken the original graph and shifted it up 2. I want to emphasize, I am not making an XY table in the sense that I'm picking x's, substituting it into the equation, and calculating y's. That's not what I'm doing. I'm picking points off the graph. Okay, that's what these are right here. And then I'm adding 2 to the y. Why am I adding 2 to the y? Because it says go 2 up. And getting these values right here and then plotting those. Okay? Now, you have to be very careful. Don't get the idea that, that I'm just plugging in values for x and calculating y. I'm not. Okay? Now, I'm going to go back and show you what to do. It's a little shorter. Okay? Let's ignore this whole XY table thing that I've drawn here. So In other words, everything below this line, let's say I'd never done it. I just have the original graph, and I know I'm going to take it and go 2 up. Okay? Well, what I'm going to do is I'm going to take this point and count up 1, 2. Then without changing the x. Then I'm going to take this point and go up 1, 2. Then I'm going to take this point and go up 1, 2. And then I'm going to draw the graph. I didn't calculate anything. It's not like I actually said to myself, gee, what's this number plus 2? No, I just took it and I counted up 2 on the actual graph. Okay? Now, which way do you have to do it? Either way is fine with me. You can either do this where you have the first way I did it with the XY, where you're picking points on the original graph and then changing the X or the Y, or you can just take the graph and move them. But whatever you do, you have to tell me this. That's your work, that you're going 2 up. You don't tell me that, I'm going to assume you made an XY table in your head and just did this by plugging in X's and calculating Y's, and I'm not going to take it. Okay? All right, let's take a look at another example. Okay, now here, notice I didn't give you any equation. Okay? I just said, given the graph of f of x, and I've drawn a graph here. So again, I'm just giving you the graph, and you're doing something to it. Okay, I'm saying graph f of the quantity x plus 1, that quantity plus 2. Remember, to figure out what we're going to do, you have to think of this as y equals. Now let's read the equation. The numbers here are the 1 and the 2. Can I put the 1 over with the y? No, I can't, so it's with the x. Is it on the same side or the opposite side of the equation as the x? It's on the same side, so I do the opposite of what it says. So I think of it as a -1, so I go 1 to the left. Okay, the 2, can I put it with the y? Yes, I can. Therefore, it's with the y. Right now, is it on the same or the opposite side as the y? It's on the opposite side, so I do the same as what it appears to say. So I think of this as a +2, and that means 2 up. Now, no matter what, you have to tell me those things, okay? Now, I'm going to go through and do it the easy way first, and then show you what to do if you made an X, like the series of tables here. Okay, so I'm going to take this point, this point, this point, and this point. And I'm just going to go 1 left and 2 up. Usually I like to do the X and Y thing, one first. I like to do the horizontal one first. So I'm going to take this point at the bottom and go 1 left and 2 up, and it gets me to right there. Then I'm going to take this point over here, this one, and go 1 left and 2 up and get that. Then I'm going to take this point and go 1 left and 2 up. Then I'm going to take this point and go 1 left and 2 up. Then I'm going to take this point and go 1 left and 2 up. Okay? Now, let me erase like the points I had on that I had picked on the original, because otherwise there's going to be so much junk written on here, you're not going to be able to tell what I did. And now I'm going to draw the graph. So what have I done? Notice the graph looks the exact same. I've just shifted it 1 left and 2 up. Okay? That's the easy, at least I find that to be the easiest way to do it. But that's if you're getting pretty good at this. Okay, so let's go back to the way you would do this if, you're just starting out, you're having a little bit of trouble with this, and that's fine. You can keep doing it this way. Seriously, it's a fine way to do it. Just takes a little longer. Okay, so let's pick points. Notice there's no place to plug in an X and calculate or a Y. Okay, so let's pick points. We got this point here, which is, what is that? 1, 2, 3, 4, 5. -5, comma 1. We got this point here, which is -4, comma -2. We got this point here, which is -3, -3. We got this point here, which is -2, -2. And we got this point here, which is negative 1, 1. Okay, so what does this say to do with this? It says okay, we want to go 1 left. What does that mean? Minus 1 to the x value. And go 2 up. That means add 2 to the y value. Now, I'm not going to show it in as much excruciation. I'm just going to actually do it. Okay, so first I'm going to do the x's. All I'm going to do is take all of these x values and subtract 1. So negative 5 minus 1 gets me to negative 6. Negative 4 minus 1 gets me to negative 5. Negative 3 minus 1 gets me to negative 4. Negative 2 minus 1 gets me to negative 3. Negative 1 minus 1 gets me to negative 2. Then I'm going to take the y values and add 2 to the y values. So 1 plus 2 is 3. Negative 2 plus 2 is 0. Negative 3 plus 2 is negative 1. Negative 2 plus 2 is 0. And 1 plus 2 is 3. And now we'll plot those points. Negative 6, comma 3. Negative 5, comma 0. Let me get rid of the original points here that I had put on there because it's going to kind of confuse things. Okay, negative 4, comma negative 1. Negative 3, comma 0. And negative 2, comma 3. And then I'm going to draw the graph. You're going to get the exact same thing. Okay? And that's it. So, what I want to point out is this is just for shifts. And shifts are the easiest thing to do, okay? But if you're having any trouble with them, make sure you stop and ask me now. I think I might go through one more example, okay? So I'm going to do this. I realize this is kind of a long video, but let's take a look here, and I'll get the example in a second. Let me just draw X and Y axes. Okay, let's say, so what is this, just another example. Let's say I want you to graph y equals the absolute value of x, I don't know, plus, let's say plus 4. Okay, now here, I haven't given you the basic graph. Okay, so remember, you either have to be given the basic graph or you have to know the basic graph by memory. Well, as I said in the last video, there are 4 graphs you need to know by memory, one of them being the absolute value. Actually, I told you the absolute value back at the beginning of chapter 2. Okay? So this is what we're going to do. We're going to say, okay, what's the basic graph here? In other words, what's the graph without the extra numbers? Is it an x squared? No. Is it an x cubed? No. Is it an absolute value of x? Yeah. Is it a square root of x? No. So the basic graph is y equals absolute value of x. And I'm going to draw that in, okay? I'm not going to make an XY table here, plug in values and calculate y. But so you should have this basic graph memorized. Now, why am I dashing it? Because it's not the answer, okay? Remember, the answer is the final one. This is the starting point. So in this case, you're providing the starting point. Remember I said you always have to have a starting point. You've got to shift something that already exists. In this case, we shifted a square root equation. I gave you the squared equation. You don't really need to know what the squared equation was for this one. In this case, we shifted an already existing graph, okay? Well, here, I didn't give you an already existing graph, all right? So you have to provide the basic graph. In other words, the thing that we're starting from. Okay, so now what are we going to do with that? Well, what's the number here? The number is 4, Okay, can I put that with the y? No, I can't, so it's with the x. Is it on the same side of the equation as the x? Yes, so I do the opposite of what it says. So plus 4 would be go to the right, so I want to go 4 to the left because that's what this appears to, that's the opposite of what this appears to say. Okay, again, I'm going to do this the quick way, and then I'll go back and do it the long way. Okay, so let's pick the point at 0, 0. I'm going to move it 1, 2, 3, 4 to the left, and I get that point right there. Let's pick the point at negative 1, 1. I'm going to go 1, 2, 3, 4 to the left, and get that point. Let's pick the point at 1, 1. Go 1, 2, 3, 4 to the left, and I get that point. And I know it's an absolute value. I know it's a v, so 3 points is good enough. So now I draw my graph. And again, hopefully I draw this without too much, I'm going to use a straight edge here. Okay, so what do we have? We have an absolute value of x graph. That's the dashed one. And again, if it's dashed, remember, it doesn't exist. Okay? So that's just the thing I'm using kind of as a start, not kind of, but that's the thing I'm using as a starting point. Everything that makes the given statement true is this thing that's solid. Okay? Now, what if you can't do it just by looking at it? That's perfectly all right. So I'm going to go back and do it kind of the longer way. Now, again, I'm not making an XY table in the sense of plugging in X's and calculating Y's. I'm picking points off the original graph that you supplied, that you should have memorized. And what would those points be? 0, 0, 1, 1, and negative 1, 1. And what we're going to do is subtract 4 to x. Okay, so I'm not going to change the y's at all. The y's are going to stay 0, 1, and 1. But I'm going to take 0, the x value of 0, subtract 4, we get negative 4. The x value of 1, subtract 4, we get negative 3. And the x value of negative 1, subtract 4, we get negative 5. And we plot the points negative 4, 0, negative 3, 1, and negative 5, 1. And those are the points that I had there. And I could just do it by moving them over. But either way is fine. It doesn't matter to me. You take your pick. And you know what? If you're having difficulty like just moving them kind of how I did, initially, make this set of tables, okay? And eventually you'll just get used to it. You do it a few times and you go, oh, I see what's happening now. So don't think you have to start off with just moving these things without making the table. It's fine if you do, it's fine if you don't. Okay, I'm going to stop there. Now's the time for you to ask me questions. Okay? Again, I can't emphasize enough. I don't intend these videos, just to be some sort of wall between you and me. They're to get you started, and then you ask questions, just like you would in class normally. Bonsuelo. Next time, what do we get? Oh, we get the shifts. No, we've already had the shifts. We're going to get the stretch, compresses, and reflections. Make sure you have the shifts down, the idea of how to read the equation. And again, how do you read the equation? Right here. First thing you got to know, can you put the number with the y? If yes, then the number changes the y. If no, the number changes the x. And then no matter which variable it's changing, if the number you're looking at is on the same side of the equation, then you do the opposite of what it appears to say. Same side of the equation as the variable. If the number you're looking at is on the opposite side of the equation as the variable, then you do the same as what it says. Bonsuelo, everybody. Have a great day.